Hey everybody, welcome to my shop. Today we're going to do a video that kind of continues on with what I started in my last video about incremental rotary encoders. So this video is not going to go really far in depth on the encoder itself. For that, check out the last video I did. I'll put a link down below. This one we're going to go over more of what the encoder can do, some different examples and stuff like that. So what we're going to do is we're going to turn this bar of LEDs. We're going to turn it up and down like a progress bar, and then we're going to use the button of the encoder as like a mode switch. Now, as far as what the mode will do, I hope you stick around and find out. Let's get started. Okay, let's go ahead and take a look at our sketch code here. We start out with our normal title block here, normal stuff. We'll continue on. Next we're going to create some constants of type byte. We've got pin A going to digital pin 2 of the Arduino. That's for our clock pin of the encoder. This is a very important one, however, because pin A, or the clock pin, is also the one that we're using an interrupt on. And with an Arduino Uno, our interrupts have to be plugged into either pin 2 or 3, so keep that in mind. In this particular case, we've got ours plugged into pin 2. We're good. Next is our digital pin B, which is the data pin of the encoder. That's going to go into digital pin 3 of the Arduino. Then we have some constants of type byte for our LED pins. They're going to go from pin 4 all the way down to pin 12. And then we have our number 10 LED going to pin 14. Some of you are probably going to say, wait a minute, 14, there is no 14. So if you look at this pin out of the Arduino Uno, on the right side, we go from pin 0 all the way up to 13. On the left side, we have analog pins. So our analog pin A0 is also able to be used as a digital pin 14. Analog pin A1 can be used as digital pin 15. And in our case, we are going to use 15 as well. We're going to use 15 as our switch pin. So that's going to go to the switch pin of the encoder. Okay, next we want to set a variable of integer for encoder position and previous encoder position. We'll go ahead and set both of those at 0. Then we need an integer for our encoder high, which is a high limit. We're going to set that to 35. We don't need to keep, when we're going clockwise, we don't need to keep turning past 35. Integer for encoder low, we're going to set that to 0. If we're going counterclockwise, once we get to 0, we don't need to go negative. So low limit of 0, high limit of 35 is good. Next, we're going to look at a unsigned long integer called previous millis, and one for current millis. We're going to set those both to 0. Then we need an integer for millis delay time. We're going to set that to 5 milliseconds. And these three variables, previous millis, current millis, and millis delay time, those we're going to be using to debounce our interrupt. Next, we need a string variable called direction. We're going to use that to store whether we're going clockwise or counterclockwise. We also need a variable called mode. We're going to make that of type byte, and it's going to store a number 1 through 3. This is going to indicate whether we're in mode 1, mode 2, or mode 3. All right, let's go ahead and take a look at our setup. First thing in our setup, we're going to attach an interrupt. It's a digital pin interrupt. We are going to attach that to pin A, and we're looking for pin A to go low. If pin A goes low, we're going to run the interrupt service routine called have rotation. And we'll get into that in a minute. Next, we're going to go ahead and open up a serial monitor. Then we're going to set our pin modes. Pin B is going to be an input. Our switch pin is an input. It will be a pull-up. And all of our LEDs are going to be outputs. All right, let's take a look at our loop. First thing we're going to do in our loop, we're going to take a snapshot of the current time. So our current millis is going to be equal to millis. Then we're going to take a look. We're going to keep an eye on our switch and make sure it hasn't been pressed. So this one has a not digital read, and the reason for that is because our switch on this encoder is always high, so it's normally closed. We are looking for when it's pressed, it'll go low. We're looking for if it's not high or not digital read switch pin. So in this case, what we're doing is when it is pressed, and it goes low, we're going to look for it and see if mode is set to 1. If mode is set to 1, we're going to make it 2. Else, if mode is 2, we're going to make it 3. Else, if mode is 3, we're going to set it back to 1. So basically, every time the mode button is pressed, it's going to rotate from 1 to 3 and back to 1. Now we do need to use a debounce. Normally I would like to use the millis. In this particular case, we're already using a lot of millis variables for our interrupt. So I'm going to go ahead and use a delay of 200 milliseconds. It does stop the program for 200 milliseconds, but that's very minor amount of time. Basically, when you press the button and you move your fingers back to start being able to rotate it, that time's already taken up. So I don't think we're stopping it long enough to really make a difference here. So next, what we're going to do is we're going to go ahead and see if our encoder is rotating. So if the encoder position is not equal to previous encoder position, it is in fact rotating. If it is rotating, what we want to do is check our limits. So if encoder position is greater than our encoder high, that means we've gone past our 35 limit. And in that case, we just want to go ahead and set our encoder position to its high. Same thing with the low limit. If our encoder position is less than encoder low, then we just want to go ahead and set it to the lowest. So basically, if we're turning it counterclockwise and it goes below 0, we're just going to set it to 0. Next, we're going to go ahead and write some stuff to the serial monitor. Every time we go through this loop, we need to take the current encoder position and make it the previous encoder position. Now we're going to take a look at what we're doing in each mode. So we're going to do a switch where we're looking at variable mode, and we're looking for, in the case where it is 1, then we're going to do this. We're going to clear all of the LEDs. So every time we switch it to a different mode, we want to basically get a clean slate. We want all the LEDs to go back to low. And we've done that down here. So the function clear LEDs basically sets all of the LEDs to its low state. So we're going to go ahead and do that. Next, we're going to go ahead and take a look at the encoder position. And if it's greater than 3, then we are going to do a digital write and make LED 1 high. Else, we're going to make LED 1 low. If the encoder position is greater than or equal to 6, we're going to make LED 2 high. Else, we're going to make it low. And this carries on. So let's say we get up here to 15. So at this point, if the encoder position is greater than or equal to 15, we're going to make it high, but all of these other ones prior to that have already gone high. So as we're turning clockwise, each one of these LEDs is going to get lit or go high and stay high. And then we've got case 2 and case 3, which we'll get into in a minute.
All right, let's go ahead and go over some of the wiring here. Breadboard's a little messy, but we're just going to go step by step. I'm going to put a schematic up on the screen here. Hopefully it's zoomed in far enough for you to be able to see. So we're going to start with our 5-volt pin of the Arduino with the red wire. We're coming over to our power rail. From our power rail, another red wire coming to our 5-volt or VCC of the rotary encoder. Next we've got our black wire, which is in the ground pin of the Arduino right next to that 5-volt. It's also coming up to our power rail, the ground rail, and then a black wire coming from the power rail to the ground of the rotary encoder. Next, let's go ahead and finish off the rotary encoder wiring here. We've got the orange wire, which is going to the clock pin, or our pin A on our program. That's going to run over here to digital pin 2 of the Arduino. Our yellow wire are going to the data pin, pin B on our program. That's coming over here to our digital pin 3 of the Arduino. Then we've got one more wire on our rotary encoder, and that's this brown wire here. That is coming over to, I believe, A1. Yes, that is A1 of the Arduino. And if you remember from the pinout, that can also be used as digital pin 15. So that will be our switch pin on the rotary encoder going to digital pin 15. Next, let's go ahead and go over all of the LEDs. So we've got a black wire here. We're coming from digital pin 4 into the analog side of LED 1, and from analog side, or the positive side, then we're coming out the negative side or the cathode side to a 330 ohm resistor and into the negative or the ground of the power rail. Now each one of these LEDs, LED 2, 3, 4, all the way up to 10 here, they're all going to do the same thing. They're going to go through a 330 ohm resistor and into the power rail, ground. Each one is being fed by a different pin of the Arduino, however. So starting off with, we already discussed pin 4, which is the black wire going to LED 1. Pin 5 is going to be the brown going to LED 2. Pin 6 is going to be the red going to LED 3. 7, 8, 9, 10, all the way up to, I believe, 11, which will be this purple wire going to LED 8. Okay. Next we have our green wire here, which is from our digital pin 12 going to LED 9. Now I don't really like to use on the Arduino pin 13 if I can help it, because that anytime pin 13 goes high, so does this LED on the board. So I just kind of stay away from that. If I've got other pins, I'll use those first. So in this case, we're going to use a pin going to A0, or digital pin 14. That's going to power our LED going to the analog, and then again coming out the negative side of our LED, or cathode side, to the resistor and to the power rail. So that should do it for both power going to the power rails and to the encoder. Our switch wires, 3 of them, clock pin, data pin, and switch wire. And then all of our LEDs coming from the Arduino over and coming back on the ground rail. Alright, we've got our sketch uploaded and our power plugged in. Let's go ahead and test it out. So I'm going to turn the Arduino to the right, or clockwise, and we are going up. Counterclockwise or to the left, we're going down. However, we are kind of going backwards. You would think if we're going to the right or clockwise, we'd be going this way. We can actually change that in our code. We can just change the pin numbers to our constants rather than having to rewire the whole thing. So let's go ahead and take care of that. Also, we want to figure out what we're going to do for our second mode.
Okay, let's go ahead and change the LED pins around. So LED pin, or LED 1, will now get LED 10's pin, and LED 10 will be LED 1's pin. Alright, let's go ahead and take a look at what our mode 2 is going to do. So in our switch statement, our case 2 is going to start out by clearing all of our LEDs. We're going to turn them all low, get a nice clean slate. Then we're going to jump down here and we're going to take a look at what our encoder position is. If it is between 3 and 6, we're going to turn LED 1 on. If it is between 6 and 9, we're going to turn LED 2 on, and so forth. If we're between 18 and 21, we're going to turn LED 6 on. So let's go take a look at it.
Alright, let's go ahead and take a look at mode 1. Still working okay. Goes up and goes down. We'll do a mode selection. And there we go with mode 2. Goes all the way across, comes back. Works perfect. If you're learning anything, don't forget to hit that subscribe button. But let's go ahead and program mode 3. So what I'm thinking is we'll go ahead and make it like work on the edges, and as we turn, we'll come into a focus. Feel free to jump ahead of me and write some code and see if we do it different.
We're back in our switch statement and we're taking a look at a case 3. This is our third mode and our final mode. Let's go ahead and look at this. So I've removed the clear LED thing that I had down here because each one of these has its own clear LED. Okay, so when we go into case 3, we're looking to see if our encoder position is between 3 and 6. We're going to clear all of the LEDs. Then we're going to write LED 1 and LED 10 to go high. If it were between 6 and 9, we're going to again clear all the LEDs and we're going to write LED 2 and 9 to go high. And we're going to continue on. So this should start out at the outer edges, and as we turn clockwise, it's going to come in and focus in the center. Let's go see what it does.
Alright, we've got our sketch uploaded with the new version. Our mode 3 is included. We've got power turned on. Let's go ahead and test it out here. Mode 1 is still working correctly. Mode 2 still working. And mode 3. That's pretty cool. So today we have learned how to use a rotary encoder to move some lights on an LED strip here, or an LED bar. We've also used the switch to be able to select different modes and how we're doing that. And that doesn't just apply to an LED bar. We can use the ability to use a mode selection like that in all kinds of stuff. So yeah, use your imagination. So I want to thank everybody for sticking to it to the end and watching the whole video. If you enjoyed this video and you learned anything from it, please hit that like button and go ahead and subscribe. Got a lot more videos coming out. With that, y'all have a great day. Thanks again. Take care.